Alright, in this video we're going to introduce a new type of variable, and that's called a static variable. So here's a program, again we used this before, that simply displays the values of the variables in their certain locations. So here we have number defined in main, that is set to 20. It calls this function display value, which sets number to 10, and then I added that we add 5 to the variable number and assign it back to number, and we output the number again. So when we call the function, we'll see the two outputs from it, and it'll come back to main. I'm going to put a cout statement in main also after the call. Alright, still no static variables yet. These are just normal regular variables. Let's take a look so we can have something to compare to once we add a static variable. Alright, so here the output as we expect. In main it tells us the variable is 20. Once we go into display value, we create a new variable called number. We set it to 10, so there's that output. We add 5 to it, there's that output for 15. Then we go back to main, and the variable is 20. Okay, so we'll keep that window around, and really just change one thing here. Change this variable to a static. And the effect it's going to have is that it's basically going to make this variable kind of like a global variable, meaning it stays around forever. It never is deleted from memory until the program ends, but its scope is only visible within this function. It is not the same number that's up in here anymore in terms of global. Alright, so this is a unique number down here, but what important thing it does, it maintains the value it had the first time it was called. Alright, so running it right now, we're not going to see much of a difference. Alright, there's the same result that we got previously. Let me bring up the other one. Alright, there's the two windows. Alright, nothing's changed yet that you can visibly see. Alright, so let's close this one out. This is still the old one. Alright, so let's change this. So with a little for loop, that's going to call it a couple times, and we can see then the result or the effect of having, and we just go 3 times, of having a static variable. Alright, so that's going to call the function 3 times. Alright, so now we'll definitely see the result of this static variable. Let's bring back the other window first. Alright, there's that one, and here's the new one. Alright, so 20 in main as we expect, go into the function, we set it to 10, and that's what we output. Then we add 5 to it, we see the 15. Alright, then it returns back to main, so then calls the procedure again. When it comes back, the first output is 15. Alright, not 10. This assignment is done once. Since it's static, it only creates the variable once in memory and keeps it in memory, so this statement of the static int number is ignored the second time, third time, and every other time you call it. The first time this procedure is called is the only time this statement is executed. So we remembered the last value it was at, which was 15, and outputted it, add 5 to it. Function ended. Normally the variables are destroyed, but in this case it's static, so it's going to stay around again. We call the procedure again, and you see that it remembered that it was 20 from the previous call, and then added 5 to it, it's up to 25, goes back to main, the loop ends, so it outputs the variable that's in main, which is still 20, which we don't expect to change. If we were to call display value again, it will remember that it ended at 25, so you'll see an output of 25, it'll add 5 to it, a 30, and then output the value of 30. So the static variable remembers the last value it had when that function was called, or the last time it was used. Alright, so it kind of behaves a little bit like a global in the sense that it stays in memory, but it does not have scope or visibility everywhere. It's still only local to that procedure. It just maintains its value between each call to that procedure function. Right.